really, it's one of these things where it's all chicken and egg. I would love to have everything that I've done for Special K as the mechanism by which I go to store and to network for block structure. But since I want to build Special K at the higher level, having assumed those, I'm kind of looking at what's the barest bones implementation I can give on top of that. So it's one of these, deciding where to make the cut. I spent this morning comparing to the Ethereum J implementation and the way they've gone to store. It's really interesting to me how a lot of these projects are just unaware of the reactive technologies and how important they are and how critical they will be, especially for the blockchain space, which is just, the blockchain is designed to be a reactive mechanism. There's just like no reason not to make the chain itself be a reactive mechanism. It's like what you really want to do, even at the lower levels, is to provide a for comprehension based interface that's kind of the form for block, from store, such that the block passes a condition.
Hey, Greg, if I can interrupt you, are you sharing a screen, or do you want to share?
No, I was just typing in the chat,
okay,
but I can share a screen. I was just typing in the chat, but I can absolutely share a screen. So let me do that.
If you could also queue up describing what's in a block, because it might look a lot different than a Bitcoin block, for example.
Right. Well, that's exactly right. I mean, at a minimum, you are still going to have this kind of Merkle-proof structure, right? So pointers to parent blocks will be hashes, hashes of the previous block or hashes of the parent block. So a lot of the structure remains the same. The content of the block structure will include essentially transactions, right? And the transaction. So we want to make a distinction between the header versus the body of the block. But that I've talked about that kind of a lot more extensively in other discussion. What I was talking about here was just kind of the API. How does one think about the block structure? And hang on one second.
I didn't mean to derail you, but at some point when it's convenient, let's come back to the block structure more.
Yeah, sure.
Right.
Oops, I want fonts. Let me see, grand is fine. But now let's do grand. We'll turn this to Menlo. And yeah, there we go. Menlo is nice. Okay, so basically, oh, come on. Here we are. Okay. So basically what we want is something like this: for block from store under the conditions that the blocks, under when the block satisfies certain conditions that's expressed by cond. Let me move this over. Then you run some program that is parametric in the block. That's the shape of the API, right? There's no reason not to have that shape, and basically all of the most processing is going to be of this form, and this naturally fits on a store that's a chain, right? Or a store that's a tree, right? So having the monadic API at this level of the structure is totally reasonable. mean, it's more than reasonable. It's what the reactive principles were made for. And the same is going to be true the other way. Instead of going from a stream, let's say instead of going from a store, let's say you're going from a stream, right? There's no there's no difference. It is exactly how you want to handle this, right? So this is a client syncing off of a node, and this is the node syncing off of the backing store, right? They're exactly the same. So providing a reasonable infrastructure for this is essentially what I've been doing the legwork on over the last 24 hours, just thinking it through and making sure that there's a nice mapping. One of the things that I thought about was, what kind of abstraction layers will get us to the metal. And I realized that, below a VM layer like the JVM or the CLR, you're really on your own. There's just the fan out in terms of the abstraction above storage and network below a managed code environment is just too great. Again, the choice of using a managed code environment like the JVM or the CLR is a much, much better choice from that perspective. Let me make sure that everyone understands what I'm talking about here. Ed, do you know what I'm saying?
Yeah, so storage is done in so many ways. It's going to be very, OS and storage system specific that that wouldn't be the specifics wouldn't be described here, but in RChain they would need to be through a foreign function interface, some connector to that storage, and it's going to look very, very low level, I guess is one way to say it.
Yeah, that's exactly right. And so the point is, in terms of time to market, you want, if you do the implementation below a managed code environment, then the fan out in terms of the number of libraries and architectures you have to support goes up through the roof.
But I got it. So I had a related question is, okay, so what is the first target hardware or target, popular VM that would be targeted?
Yeah, so then again, what that does is that shores up the implementation choices that I've been suggesting, which is that we do a clean room reimplementation of the Rosette VM on top of via Scala, right? So since the implementation is via Scala, we have at our disposal all of the JVM infrastructure. And this, by the way, is not very much different than the Ethereum J implementation, right? The Ethereum J implementation, even the virtual machine even the Ethereum virtual machine is running inside the Java virtual machine. So that's a natural implementation path. The thing that has been, kind of most disconcerting to me has been, the Rosette implementation, the C++ implementation is tuned, right? That thing, I'm pretty sure that we can easily compete with a little bit of jitting. We can easily compete with the Java VM.
So some of this is new to me. Maybe you talked about it on the Casper Hangouts before, but I haven't been attending some of them because
yeah, I get it.
I mean, it's early, and then plus I just wasn't expecting all these topics to be talked about in the Casper Hangouts. So can you describe via Scala a little more? It's the first I've heard that.
Just through Scala, right?
Oh, okay, got it.
So we're like if you go look at hang on, let me go find Ethereum J.
So in the architecture document, we were describing using a foreign function interface directly to the storage and the messaging layers, but you're saying that actually it'd be something else in between there.
Well, I'm suggesting that path to market, we unwind that down to a foreign function interface later. I mean, when you go through the JVM, ultimately you're going through a foreign function layer. But the question is whether we go directly from the Rosette VM, or whether the Rosette VM, at least in the 0.1 implementation, lives, that we release at the end of this milestone. So let's go here, and then if I do a clone.
So are you saying the Rosette VM will initially run on the Java VM?
Well, initially it runs right now on C++, right?
Right.
So what I'm saying is that we do a new implementation on top of the JVMs. And so let's take a look at it. We want to GitHub, Ethereum. So let's go there.
I mean, this sounds like what I hoped you were doing.
Yeah, well, I mean, this is what we've been talking about. The only temptation was possibly to go straight to the C++ implementation, and that has pros and cons. But one of the things that I was talking about in terms of the cons was that the fan out to the storage layer is pretty intense, right? Below some managed code level, the fan out to storage abstractions is much worse.
Yeah, this seems super flexible.
Yeah, exactly. So I mean, if you look here, right, if you look inside of the Ethereum J core, and the source, main, Java. Okay, so the VM is sitting right here, right? And so it runs, they don't do a bytecode compilation to Java bytecode, right? They have their own little bytecode widget, and then they have a loop which reads the bytecodes, right? That's how it works, as near as I understand from reading the code.
So it reads the EVM bytecodes and translates them to Java.
To Java calls. That's exactly right. So that's exactly what would be happening.
Except we would be doing them to Scala calls.
Well, Scala, Java, ultimately that's all compiled to JVM, so we don't care about that, right?
Yeah. Well, I'm just curious. Yeah.
Yeah. Okay. So now if we go, right. So essentially what we would be doing is re-implementing this code here. Oh, sorry. Hang on. We would be re-implementing this code that I'm showing here, but on top of the JVM, right? So this switch here, the VM execute, right? So it's got a bytecodes array, switching on each bytecode, running the bytecode, and instead of the bytecodes implementations being in C++, they would be in Scala. So that's the idea, and that gives you. I mean, we're kind of far afield from what I wanted to talk about, but this implementation strategy, or this implementation path, which is what I've been pursuing the most heavily, allows us to head off the storage layer fan out, and that's what I'm mainly interested in, is trying to get to a storage layer abstraction that is uniform with respect to all of the other abstractions, right? And what I was trying to argue was that, this is exactly the abstraction we want for applications that are even sitting at this level, right? Applications that want to sit at this level, they want to treat the chain, whether it's coming from syncing as a client or coming directly from the backing store, they want to treat it in this fashion, with the monadic semantics that I've identified in Special K and others have identified, for example, in Reactive Mongo and other places. This is the kind of abstraction that we want, and that makes our lives and programmers' lives much, much simpler. So that's the kind of design work that I've been doing in order to get to the shortest possible implementation path, so that we can have something to show. And what I would like to do again, no promises, but I'm hoping to have at least some demos of this kind of capability in the next few weeks, so that so people can see for themselves what I'm talking about and understand what it means to have a reactive style access to the chain. So that's kind of what's been driving me, is to make sure that people, especially developers, get a sense of what it would be like if they had a reactive style. And once that happens, then it's kind of a brainwashing effect, right? Because now whether you're writing in Scala or you're writing in Rolang, it's exactly the same kind of construct for most of your programs. Most of your programs are reactive in the sense that you're waiting for some event to happen, right? So here's the detection of an event that's happening from place, whether it's backing storage or stream. And then as a result of the event that happens, then you take some programmatic action, right? So that's the key idea, right? Here, if you have a block and the block contains a bunch of transactions, so now it's a block structure, what are those transactions? Well, really, those transactions are transitions in a virtual machine, right? That's what they are. So in terms of the Rosette calls, most of those transactions will be either an exmit or a send in terms of the VM opcodes here. So let me see if I can find this for you.
I had a question about how much of a transaction is needed to be serialized or stored in the block. So I'm trying to in Ethereum there's as I understand it, there's two types of transactions. There's sort of the UTXO type, and then there's the full smart contract that in that case the transaction is storing the message and the whole state of the VM, where the UTXO style is very compact, right?
Right. But in general, right. I mean, the vast majority of the cases end up being the contract style rather than UTXO style.
Okay, so I guess my question for RChain.
Let me put it this way: we're not optimizing for ledger behavior. We're optimizing for contract behavior.
Okay, that answers my question.
Yeah. Right. Cool. All right. So I think that's basically my update in terms of Casper. I'm focused right now on getting the putting all the pieces together so that we have a reactive style chain that people can play with. And once we have the reactive style chain, then the next step is to put the consensus algorithm on top of that, right? But the consensus algorithm, first of all, it's consensing over a particular state, and that state has to be represented both on storage and on the stream. And so that's why, we have these sets of dependencies that are linked in exactly the way that I've been exploring them. Does that make sense?
It does. I like it.
Awesome. Sweet. That's very
nice.
Cool. So let's see. Are there any other burning questions?
Well, if we could cover block structure just a little bit. So mainly I want to, so I tracked what you were saying. I want to get some more words about it into the architecture document. And I think given what you've said, I could probably draft the section now. Let me just replay what I thought I heard. So it'll have a header and a body. The header will point to parent blocks. I think there still needs to be a bit more described about the structure of all the blocks. Isn't going to be quote unquote linear, or as nice and linear as some people.
Oh no! I mean, there's lots of optimizations here to
right.
consider. I mean, just as an example.
Let me finish.
Yeah, go ahead.
So the block structure itself is going to look different than Bitcoin and Ethereum. I mean, in terms of I guess the high level structure of the chain.
Yeah.
And then the headers, so that So it's going to be a graph. And then inside the body are just going to be a bunch of serialized contract states that are essentially transitions,
Right.
transactions.
Right.
And for integrity, there'll probably be Merkle root kind of integrity checks going on as well for.
That's correct. Yes, that's exactly right. Yeah.
And that could be used for search as well, but that's
correct. That's
secondary.
Yep.
A little bit more trivial compared to all the other things going on.
Yeah, that's correct. That's exactly right.
Okay.
I mean, one of the things that would be really nice. I mean, what I'd really like to get is a relationship between, you know, if I could have a Prolog unification to hash structure in place, then we could really seriously reuse much of special K.
I knew you'd be thinking along those lines.
Oh yeah. I've been thinking quite a bit. The thing is that you know there was active research in the 80s and 90s on exactly this kind of thing to make Prolog really scream.
Yeah.
But no one. I didn't see a paper that like knocked my socks in terms of, oh yeah, this gives us, you know, the kind of 80% coverage that we would want out of a heuristic approach.
Yeah.
Mike and I started looking at it ourselves, but I didn't want to devote a bunch of research onto that because there's so many other fish to fry. But it would be a really nice algorithm to have in the pocket, and you know, maybe what I can do is just put a call out there, use this channel to put a call out there and see if anyone knows folks doing work on this in this area.
Actually, make it easier for clients.
Yeah, exactly. Because then clients can do all kinds of fancy search.
Right. I need this contract in this state. Please give it.
Absolutely. And you know, I mean, that would be the reason. You know, like, yeah, it really, it's one of these chicken and egg things, right? I want to build special K on top of this, and I want to build this using special K.
Reflection's your friend, yeah.
Yeah, that's exactly right.
That's there.
Yeah, that's correct. That's right. Yeah, cool. All right. Well, any other questions that you had, or anyone else? Awesome. I'm happy to call it for today. And I don't know if you heard Jim, but I think we're going to do an informational. He has some governance discussion that he'd like to go through at 10. And I think, you know, Christian, if you're recording, can we start recording now?